Oxidation number of the chlorine. HCl HClO, that is hypochlorous acid, +1. HClO2, that is chlorous acid, that is +3. And HClO3, that is chloric acid, that is +5. HCl4, that is for perchloric acid, that is O7. Strength of acids directly proportional to oxidation number. So the order will be HClO4 greater than HClO3 greater than HClO2 greater than HClO. Determine the oxidizing and reducing nature of the substance first. If we effective element to determine the oxidizing and reducing nature of the substance A. If effective element in a compound is present in maximum oxidation state, then the compound acts as oxidizing agent. Example: KMnO4, K2, Cr2O7, H2SO4, HO3, H3PO4, HNO3, ClO4, that is +7 +7 +6 +6 +6, this much states. If element in compound is present in intermediate oxidation state, then the compound can act as oxidizing agent as well as reducing agent. HNO3, HNO2, H3PO3, SO2 and H2O2. If the element compound present in intermediate state, then the compound can act as oxidizing as well as reducing. Yes, this can act as oxidizing as well as reducing. Next, to determine the molecular formula of the compound, to calculate the equivalent weight of the compound, the equivalent weight of the oxidizing agent is the weight which accept 1 mole of electron in chemical reaction. A. Equivalent weight of an oxidant, that is get reduced. Then molecular weight by number of electron gained by 1 moles. Molecular weight by number of molecules electrons gained by 1 mole. Example: in acidic medium, 6 electron plus Cr2O7 2 minus 14H plus 2 Cr3 plus 7H2O. Here atoms which undergo reduction is Cr, its oxidation state is decreasing from +6 to +3. Equivalent weight of K2Cr2O7 is molecular weight of K2Cr2O7 by 3 into 2. How 3 into 2? Charge is 3 into 2. Molecular weight by 6. Yes, molecular weight by number of electron gained 1 mole. तो 3 था, 3 इलेक्ट्रॉन 2 मोल में, तो 3 to 6. 6 in denominator. 6 in denominator indicates 6 electron where 3 is gained. Where gained by Cr2O7 minus, as it is clear from the given balance equation. B. Similar equivalent weight of reductants get oxidized. Molecular weight by number of electron lost by 1 mole. In acidic medium, C2O4 2 minus gives 2 CO2 plus 2 electron. Here total electron lost is 2. So equivalent weight is equals to molecular weight by 2. C. In different condition, a compound may have different equivalent weight because it depends upon the number of electrons gained or lost by that compound in that reaction. Yes. Acid-base reactions. In the acid-base reaction, in case of acid-base reaction, the valence factor is the actual number of H plus or OH minus replaced in the reaction. The acid or base may contain more number of replicable H plus or OH minus than actual replaced in reaction. Valency factor for Base is number of H plus ion from the acid replaced by each molecule of the base. Keynote: valence factors calculation. For elements, valence factor is equals to valency of electron, but for acid, valence factor is equals to number of replicable H plus ions per acid molecules. Train your brain. Question: 2NaOH plus H2SO4 plus gives Na2SO4, that is plus 2H2O. Base, and this is acid. Answer: valency factor of base is 1. How? Because only one electrons are transferring, or one H plus is transferred. Let's see what to say. Here, two molecule of NaOH replaced 2 H plus ion from the H2SO4. Therefore, each molecule of NaOH replaced by 1 H plus ion of acid. So, valency factor is 1. Each NaOH is replaced by H plus. Okay. Limiting reagent we have to see, which is the limiting factor. Salt. In a non-reacting condition, valency factor is equals to total number of positive charge or negative charge present in the compound. Yes. Calculate the valency factor of the following: Na2CO3 Fe2SO4 3 FeSO4 7 H2SO gives valency factor 2, and equivalent weight is equals to m by 2, and in this 2 into 3 gives 6. So valency equivalent weight is equal to m by 6. FeSO4 7H2O, 2 electrons. Yes, so m by 2. Train your brain. Na2CO3 plus HCl, HCO3 plus NaCl. It is base, it is acid. Let's see answer. Answer: it is the acid base reaction. Therefore, valency factor for Na2CO3 is 1, while the non-reacting condition it will be 2. When non-reacting condition it is 2, and for Na2CO3 it is 1. Equivalent weight of the oxidizing or reducing agent in a redox reaction. In case of redox change, valency factor, that is equals to total change in oxidation number per molecule. Okay, it is totally based on oxidation number, valency factor. So train your brain. KMnO4 plus H2O2 gives Mn2 plus O2. Mn in KMnO4 is going from plus 7 to plus 2, so the change in oxidation number is plus 5 of KMnO4 molecules. So the valency factor of KMnO4 is 5. The equivalent of the weight of the molecule will be molecular mass by 5, so m by 5. How to identify whether the particular substance is an oxidizing or a reducing agent? Find the oxidation state of the central atom. First, if oxidation state is maximum oxidation state, then it is oxidizing agent. If oxidation state is minimum, then it is reducing agent. And if oxidation state is intermediate between maximum and minimum, then it acts as both reducing agent and oxidizing agent. It can be proportional as well as disproportionate as well as, okay, means intermediate will have maximum or minimum, it will be disproportionate reaction. It can be act as both reducing as well as oxidizing agent. Then redox reaction. What is redox reaction? A reaction in which oxidation and reduction simultaneously take place, it is called a redox reaction. In all reaction, the total increase in oxidation number must be equal to the total decrease in oxidation number. Therefore, 10Fe2 plus SO4 plus 2KMNO5 plus into O4 plus 8H2SO4 gives 5Fe2 plus 3 thrice of SO4 and 2MnSO4 plus 2 K2SO4 8H2SO H2O. Therefore, here we go. Type of redox reaction. Chemical here is chemical combination reaction. The redox reaction in which the compound are formed by combining of two or more element with each other or with a compound. With each other or with a compound. Example: A plus B gives AB. Next, that is carbon plus oxygen will give carbon dioxide. Sulfur plus oxygen will give sulfur dioxide. Methane plus oxygen will give carbon dioxide plus H2O, 2 molecules. And decomposition reaction, the redox reaction in which the chemical compound chemically split into two or more simple substance, that is A plus B gives the A plus B. Okay, AB gives A plus B, so it is called decomposition reaction. Okay, you can see this decomposition of water, decomposition of potassium chloride. This is now displacement reaction. Displacement reaction is a redox in which the place of one species in compound is taken up by others, means the position is changes. Like A plus BC gives AC plus B. Zn is displaced, means copper is displaced by Zn here. In non-metal displacement redox reaction, generally hydrogen get displaced and rarely oxygen. Means mostly the hydrogen is displaced in non-metals and that after oxygen is rarely. So NaS H2O, so NaOH is gone, so in zinc the ZnCl and H2 is remained same. Okay, so mostly the hydrogen is displaced. Mostly, means generally, but get displaced and rarely oxygen is rare. Disproportional reaction in which the oxidation as well as reduction occurs simultaneously, means a single can give oxidation as well as reduction. A redox reaction in which the same element present in a particular compound in a definite oxidation state is oxidized as well as reduced simultaneously. This is disproportionation reaction. Disproportional reaction are a special type of redox reaction. One of the reactant in the disproportionation reaction always contain an element that can exist in at least 3 oxidation state. The element in the form of reacting substance is the intermediate oxidation state, and both higher and lower oxidation state of the element are formed in the following in the reaction. For example, hydrogen peroxide dissociation. Okay, and this is, don't know what is hydrogen. Okay, this is, let's see. Next is keynote. Reverse disproportionation is the called cum proportionation. Okay, reverse of disproportionation is known as cum proportionation. In some of the disproportionation reactions, by changing the medium from acidic to basic are reversed. The reaction goes on backward direction and can be taken as the example of cum proportionation reaction. Okay, after HiO3 plus Hi will give I2. Okay, this is composition reaction. H2 is removed. Consider the following reaction. KClO, okay, KClO plays a role of oxidant and reductant both. Hence, Cl present in KClO3 is reduced and O present in KClO3 is oxidized. Since element is not oxidized and reduced, so it is not disproportionation reaction, although it look like one. Okay, it look like one. Yes, list of some important disproportionation reaction.